Okay, welcome back, mathletes. Today we're going to be taking a look at the 2024 State Sprint Round. This just came out a few days ago. We're going to go through some of the problems. I'm going to go through the middle third of the tests, so problems 11 through 20. So get ready. I would encourage you to pause the video and try to work out the problems on your own before you watch the solution. So yeah, let's go ahead and jump right in. So let's see. Here's the first one. This is problem 11. It says the distance that an object falls from rest in a vacuum is proportional to the square of the time it has been falling. So that's saying that the distance is proportional, so it's some constant times the time that has been falling. The square of the time that has been falling. So we put t squared. So we know that this is true. Whatever the time is, you square it, multiply by some constant, you'll get the distance. And then it says if a Holstein cow plushie takes 3 seconds to fall 144 feet in a vacuum, 3 seconds for 144 feet, how far does the plushie fall in the first 2 seconds? All right, so what we can do is we can say this constant k is just going to be t squared divided by d. Or you could take the reciprocal and say that it's d divided by t squared. But regardless, the distance divided by t squared or t squared divided by the distance, those are going to have to be the same for different times. So we can write in for 3 seconds and for 2 seconds. Maybe I'll use this one so that we can get the distance in the numerator. So we got 144 is the distance divided by time squared is 9 because we've got 3 seconds for the 144. And then they want to know how far, so that's our x. How far is the distance? Does it falls in the first 2 seconds? 2 squared is 4. So it's just a matter of solving this equation for x, which is going to be 144 times 4 divided by 9. And the 9, this is 12 squared, so this will, the 2 3's and the 12's will cancel. We'll just have 4 squared here. So 4 cubed is going to be our answer. 4 cubed is 64. So our answer is 64 feet on that one. All right, excellent. Let's go ahead and move on to problem 2. So this one says, Jamila weighed 5 giant pumpkins for the state fair. The weights in kilograms of all her pumpkins are integers. The median weight of the 5 pumpkins, the mean and median weight of the 5 pumpkins are both 73 kilograms. And if the weight of the 2 pumpkins, if the weight of 2 of the pumpkins are 73 and 77, what is the least possible value for the range of the weights? All right, so we know we've got one pumpkin that is 73, right? So this one's 73. And let's draw a line here. We know we've got another one that's up here at 77. And we also know that our mean and our median, so I don't know, I'll put a symbol, maybe a triangle for the mean because it's balancing about that point, and our median, let's just put an asterisk for the median. These are both also 73. And it wants to know what's the least possible range of the weights. So right now we have just from these 2 pumpkins, we already have a range of 4. We'd like to keep it from expanding as much as possible. But we know we're going to have some pumpkins that are lighter than 73 in order to bring the mean down to 73. If you think about it, we've got 1, 2, 3, 4. The 77 is bumping up the sum of our pumpkins is bumping it up by 4 compared to the mean. And so we're going to have some other pumpkins that go down. We're going to need to have them down below 73 by at least 4 in total. So you might say, oh, well, could I have my range only go down to 72? And the answer is no, because if you put those other 3 pumpkins all at 72, first of all, your median is going to be 72, which doesn't work. We need our median to be 73. And our mean is still going to be up above 73 because we've only gotten 3 down when we wanted to go. We needed to go 4 down from 77. In other words, I'm kind of subtracting 73 from everything and saying this is 0 and this is 4. And if I sum up, this is -1. If I sum up the pumpkins, they have to add up to 0 so that my mean is here. And here I've got -3 and 4. They're not going to sum up to 0. So I need to at least have 1 down at 71. And I'm going to cross these ones out for a minute. Okay, so I've got one at 77, I've got one at 73, I've got one at 71. Just from those three, my median is here. But my mean has only come down, well, it hasn't come down enough because I subtracted 2 here and I added 4 here. This is minus 2 here. So I could add another pumpkin down here. Now I've got my minus 4 from these 2 pumpkins, and so my mean is now balanced, but I still need to add one more pumpkin in. So I can add that pumpkin in right here at 73. That will keep my mean at 73, and it'll put my median back at 73 as well. So that's the best you can do. The total range is from 71 up to 77, which is 6 kilograms of range. All right, excellent. So let's see what we can do here. So here, this one says there is a unique time. There's a unique time between 2 and 3 o'clock at which the minute and the hour hand of a standard 12-hour clock form a 180-degree angle. How many hours after 2 o'clock is this time? Express your answer as a common fraction. Okay, so at 2 o'clock, you've got the minute hand pointing straight up, and you've got the hour hand pointing off at an angle, right? So on the clock, you've got 12 here, and 1 here, and 2 here, and 3 here, and so on all around the clock. And what is this angle? This is a 60-degree angle, right? Because it's 2/3 of the way to 3, which would be a 90-degree angle, or you could think about it, it's 12, or 1/6 of the way around the clock, because you've got 2 out of 12. 60 degrees here. And what's going to happen as time goes forward? What's going to happen is that the minute hand is going to start moving clockwise, and the hour hand is also going to start moving clockwise, but at a slower rate. And eventually, the minute hand is going to catch up to the hour hand, and then after some more time, it'll be ahead of the hour hand, and eventually it'll be ahead by 180 degrees. So let's just keep track of how far ahead of the hour hand the minute hand is. At 2 o'clock, how far ahead is the minute hand? Well, it's negative because it's actually behind the hour hand. So at 2 o'clock, the minute hand is ahead of the hour hand by negative 60 degrees. That's how far ahead it is because it's 60 degrees behind. And then what's going to happen? That value is going to just keep going up, right? Because the minute hand is moving faster, so it's going to continually move up. At some point it's going to hit 0, at some point it's going to hit 180, and then by 3 o'clock, what's it going to be? At 3 o'clock, how far ahead is the minute hand going to be than the hour hand? Well, at 3 o'clock, it will have gone all the way around, but the hour hand will now be pointing at the 3. So it will be ahead by this angle, 270 degrees. 270 degrees. So what has happened is we've got a linear function that goes from negative 60 degrees to 270 degrees within 1 hour. You could plot that. You could say, okay, here's 2 o'clock, and here's 3 o'clock, and it goes from negative 60 all the way up to 270. So this would be negative 60, this will be 270. And so really it's just a matter of finding where does it cross this threshold of 180. Where does it cross 180? When it gets to 180, those will be exactly opposite of each other. All right, so how do we do that? We just take 180 minus a negative 60 divided by the total. So that's like the difference between these two numbers. And then we need to divide that by the difference between these two numbers to tell us how many hours it's been in this time. This time, some fraction of the total, and it'll be, since it's linear, it'll be just the difference between these two angles divided by the difference between these two angles. So this is going to be 270 minus a negative 60. I'm going to put that in parentheses. So this is equal to 240 on the top divided by 330. And if you divide both the top and bottom by 30, you get 8/11. So that's 8/11 of an hour, and that's your answer you would put up here, 8/11. Now, one thing that's interesting is this is not an even number of minutes. So if you tried to do this in minutes or something, I mean, it wouldn't really help you. It's really nice to just do this in in hours. Like you wouldn't be able to think of an actual time when it'd be exactly opposite if you were trying to think about this in integer number of minutes. Just kind of, so this is really a nice way to do it. All right, great. I hope you enjoyed that one. Let's move on to the next one. So this is problem number 14. And let's see, what do we got here? So this one says Robin can travel from Lincoln to Omaha. Okay, so we've got Lincoln to Omaha in 4 different ways. Okay, she can go this way, she can go this way, she can go this way, or she can go this way, right? Lincoln to Omaha in 4 different ways. And from Omaha to Des Moines, this is Des Moines over here, in 3 different ways. So she can go this way, or this way, or this way. How many different round trips can Robin make from Lincoln to Des Moines? Okay, so she's going from here to Des Moines and back. That's what a round trip is. It's going from Lincoln to Des Moines and back. That pass through Omaha in both directions. Okay, so she has to go from Lincoln, pass through Omaha, get to Des Moines, then pass through Omaha and get back to Lincoln. Okay, well, one way to think about this would be to say from Lincoln to Omaha there's 4 ways. From Omaha to Des Moines, to Des Moines, there's 3 ways. And then from Des Moines to Omaha, there's 3 ways. And then from Omaha to Lincoln, there's 4 ways. And so since the number of unique trips would be just the multiplication of all these numbers. So there's 4 different, it's kind of like if you say I have 4 different hats and 3 different shirts and 3 different pairs of pants and 4 different pairs of shoes, how many different outfits can I make? You just have to multiply them all together. So this will be, there's 12 here and 12 here, we can multiply those to get 144. So there's 144 round trips. All right, great. Let's see, so number 15. This one says, in triangle ABC shown here, point D is on the side AC such that AB equals AD. Okay, so these two are equal. They showed us that. That's great. And then they said the measure of ABC minus the measure of ACB. Okay, so that's, see, that's this angle here minus this angle here, right? And that's 30 degrees. So if we call this one Y, this one over here would be Y plus 30. Okay? And then they want to know the measure of angle DBC. DBC, this one with the question mark here. Okay, well the nice thing is we know that this is an isosceles triangle. And we can use the fact that the angles of a triangle sum up to 180 degrees. Alright, so what that means is that this angle here is going to have to be 180 minus, so 180 minus the sum of these 2 angles. So minus 2y and then minus 30. And then these 2 angles here and here, those are going to each be the same because you have an isosceles triangle, and when you add those 2 up with this thing, you're going to get 180. So basically they each have to be half of this thing you're subtracting. In other words, yeah, they have to be half of the sum of these 2, right? So that half of that is going to be y plus 15. So this is y plus 15 here. We don't actually need that one over there, but this one here is also y plus 15. Now, if you're looking for this x angle here, that's going to be the difference between this bigger angle and this smaller angle. We know both of those. So x is going to be equal to, I think that color doesn't show up very well actually. X is going to be equal to y plus 30, which is the bigger angle, minus y plus 15. Okay, so if we subtract y plus 15 from y plus 30, we just get 15 degrees, which is our answer. Okay, so 15, problem 15, we had an answer of 15. How about that? Okay, let's take a look at number 16. Okay, this one was a tricky one, and it was a little bit of a trap. So normally when you look at a problem like this, you say, oh, let's start at the innermost part, let's compute that thing, then we'll move out to this outer part here, we'll do the same thing over here, and you might say, oh, look, this thing is the same as this thing, so I'm definitely going to compute that because that's going to be an important thing, I get to use it twice. Well, that's a trap. You're going to waste a lot of time trying to figure out what this is by plugging it in here. And the reason you don't actually need that part is that if you look at this entire thing in brackets and you compare it to this other thing in brackets, okay, what you'll notice if you have a keen eye is that one is the negative of the other. So if you call this one z, for example, this one will be negative z, okay? And what happens when we do this little snowflake thing on two things that are the opposite of each other? Well, you can just plug it into this equation. So our x will be z, our y will be negative z, so x plus y will be z minus z, which is nice, it just cancels out, plus z times negative z, that is negative z squared, all divided by z squared. And of course these cancel out, that gives you 0. And now we just have negative z squared divided by z squared, which is just equal to negative 1. So the answer is negative 1. It was actually a really easy problem if you spot that difference. If you don't spot that difference, you'll spend a long time trying to work this one out. So, all right, let's move on to number 17. This one says the top row of this figure shows the letter printed on the front side of 6 cards, and the bottom row shows the image printed on the back side of the corresponding card. So this is the same card, in other words. This card has an A on one side and this yin-yang symbol on the other side. And it says, when Josie shuffles the cards and deals the first card front side down, the back shows this symbol. Okay, so we know that that first card is one of these 3 cards. What is the probability that the next card she deals has the peace sign or A on either side? Express your answer as a common fraction. Okay, so which cards is it that would satisfy those conditions? So there would be this one. Let's see. There would be this one. One second. There would be this one here. That has an A on this side, and then these 3 over here, right? This one, and this one, and this one. Those are the 4 cards we're looking for. So basically what we're saying is if she lays one of these 3 cards down first, what is the probability that one of these 4 cards are going to be next? All right, now, here we have a case of a probability problem where an event depends on another event. In other words, the first card could be this one here, or it could be one of these 2. And you'll get a different probability for getting one of these 4, depending on whether the first card was this one or one of these 2. So we have to do those 2 separately and add them up. So there's a third of a chance. Let's see, I'm going to grab yellow. We'll do it that way. There's a third of a chance that she, because there are 3 of these cards that it could have been, the first card, there's a third of a chance that it's this first one. And in that case, there is 3/5 of a chance that the next card will be one of those 4, because it can't be this one. So basically there's 5 cards left, all these ones here, and 3 of them have this peace sign on the back. So that's going to be a third times 3 out of 5. So that's the probability that she laid down this one and then one of these 3. We have to add that to the probability that she laid down one of these 2, which is 2/3, times the probability that under that circumstance, in other words, under the case where she laid down one of these 2 cards, what is the probability that the next card is going to be one of the blue ones? So in that case, if she lays down one of these 2, there will be 5 cards left, and 4 of them will satisfy that condition. So we'll have 4/5. We're going to multiply that by 4/5. So we can just do the math here. We have, look, the 3's cancel there. We have a 5th plus 8 over 15. This is going to be 3 over 15, so we have 11 over 15 as our final probability on this one. So that's our answer right there. All right, great. We're making great progress here. Let's move on to number 18. So this one is about a quadratic equation. It says we've got y equals ax squared, y equals ax squared plus bx plus c, and a, b, and c are constants, so that means we have a parabola here. the function intersects the x-axis at negative root 6 and positive root 6. So those are the roots of the polynomial. And it says it intersects the y-axis at 2. What is the value of a plus b plus c? Well, the first thing we could do is plug in 0 in for x, because that will help us figure out something about a, b, and c. So let's do that. So if we say y, well, in that case, y is going to be 2. So we can say 2 is equal to ax squared. What's ax squared? Well, x is 0, so that's going to be 0, plus bx. Oh, x is 0 again, plus c. Oh, that just tells us that 2 is equal to c. Okay, great. We're a third of the way there. We've got c. We just need a and b. All right, now let's take a look at the quadratic equation. So this will tell us our two roots, which are these two here. So our two roots are going to be minus b plus and minus the square root of b squared minus 4ac. Now, we already know c is 2, so I guess I can write, well, why don't I just write 8a for that, because I know that c is 2, so this will be, oops, this will be 8a, all divided by 2a. Okay, so we can split this into two parts. There's the constant part over here, and then the part that's plus or minus, right? The radical part, the discriminant part. So this part has got to be 0, because the vertex of our parabola is centered right at 0. So the plus and minus, that square root thing, is going to take us to these symmetrical roots here. So this b has to be 0. So we have 0 equal b. We're already 2/3 of the way there now. So let's plug that in. Now we just have plus and minus the square root of b squared is 0. So this is just minus 8a. And then maybe we'll bring this 2a into the radical, which means we have to turn it into 4a squared. So 4a squared, is that right? I think so. All right, so, and we know that that is equal to plus and minus the square root of 6. Okay, so that means that minus 8a, well, I can simplify it a little bit, because this 8 and this 4 can cancel down to 2. So minus 2a over, and it's the a can cancel with one of these a squared. So it's really just minus 2 divided by a is equal to 6. All right, so I can multiply by a over 6, and I get minus 2 over 6 is equal to a. So now I know a as well. That's also, if I simplify that, that's minus 1/3. So maybe I'll write that a equal minus 1/3. So now I have all three of these. And what did they want to know? They want to know the value of a plus b plus c. So we just add these three together. This one's 0, but we have 2 here, and then a minus 1/3. So that gets us down to 1 2/3, or if we put it as a common fraction, that will be 5 over 3. So we can put 5 over 3 for our answer. Since 2 is 6/3, minus 1/3 would be 5/3. Okay, great. Let's take a look at this one. This is number 19. Just two more problems left. This one says if a, b, and c are all positive integers greater than 1, for which a plus ab plus abc equals 415, what is the value of c? Okay, so we've got, let's see, we've got a plus ab plus abc equals 415. Now, we can factor out an a here, so this will be a times 1 plus b plus bc, and so that's equal to that. And then we can also, in this part, we can factor the b out. So we have a times 1 plus b times 1 plus c, and then 2 parentheses at the end there. So that's going to be equal to 415. All right. Well, we've got two numbers. We know these a, b, and c are all integers, and they're also integers greater than 1. So that means that we could maybe try to find the factors of 415 and see, because we've got two numbers multiplying together to give us 415. So what is 415 divisible by? It's not divisible by 2, not divisible by 3, because if you add the digits, you can see that. Well, it's divisible by 5, actually, right? It's got a 5 at the end. So let's divide it by 5. If we do 5 into 415, we get 8 there, 40, it's 83, right? So 83, and 83 is a prime number. Okay, so we know that these two numbers have to be 5 and 83. Okay, now what if we say that A is 83? Could we have this number be 5? And the answer is no, because B and C both have to be positive integers greater than 1. The lowest they could possibly be is 2. And if you put 2 here and 2 here, this thing is going to definitely be greater than 5. So we can't have that. So that means that this A has to be 5, and this one has to be 83. All right, well, we can subtract 1, and we have B times 1 plus C. Whoops. 1 plus C has got to be equal to 82, because we subtract this 1 here. Now, what are the factors of 82? Well, 82 will be 41 times 2, and 41 is prime. So one of these has to be 41, and the other one has to be 2. The thing is, this one here can't be 2, because C already has to be at least 2, and if you add 1, it'll have to be at least 3. So that means this one has to be 41. This one here, 1 plus C. And that means B has to be the 2. I shouldn't draw that line because it looks like a divide. It looks like I'm dividing and I'm not. So B is 2, and this 1 plus C is 41. So that means that so we had A equal to 5. So A is 5. B is 2. What do they want to know? Oh, they only want to know the value of C. So we don't need to worry about A and B. C is just going to be 40, because 41 is 1 plus C. So C equals 40. That's our final answer. We'll put it up here, 40. All right, great. We got one more, and then we got the really hard problems in the next video. Oh, this one's pretty hard too. All right, let's take a look at this one. So this one's about a right circular cone. It has a height of 12 meters. So we have 12 here, and we have a cone. We don't know the base size. So I didn't draw that perfectly, but we've got a cone like this. The height is 12, and it's a right circular cone. And the surface area is 90 pi meters squared. And then they want to know the volume of the cone. So the main thing we want to solve for here is this radius, R. There's also this diagonal here, D. You can make a right triangle here and use Pythagorean theorem to relate 12 and R and D. Those are all going to be important parameters. So let's take a look at this. First thing to do is, since we know the surface area, let's write down the formula for the surface area. So the surface area is going to be equal to the area of the base, right? That's just pi r squared. Pi r squared plus the area of the top section of the cone. Now, one thing that I think is useful, if you don't remember, I never remember the formula for the surface area of a cone, but you can think about unwrapping, taking this cone, just the top part, right, and cutting a slit and unwrapping it. And what you'll get as you do that is kind of a sector of a circle. So you've got an entire circle here, and you'll just have this section here when you unwrap the cone. And the radius of this sector, which is part of this disk here, is going to be D. And there's going to be some portion of the circumference of the circle that's covered here. Let's call that C1, I guess, circumference 1. That's going to be the circumference of the base of the cone. And then there's a C2, which is, C2 is not just this section, but the whole thing, the whole circumference. So the area of this sector is going to be the remaining part of the surface area of the cone. And it's going to be some fraction of the whole area of this circle. So the whole area of that circle would be pi times d squared. D is not diameter, it's a radius, but it was this diagonal, that's why we called it d. That was a little confusing. So pi times d squared, but we just have a fraction of that, so I'm going to multiply by some fraction. And that's going to be c1 divided by c2. c1 divided by c2. Okay, well c1 is equal to this circumference, which is 2 pi r, and c2 is this circumference, which is 2 pi d. And so c1 over c2 is just going to be r over d. Okay, so we can replace this bit by r over d. And if we simplify a little bit here, this is going to be equal to, I'm going to keep pi out here all by itself, and then we multiply that by r squared plus, we've got d squared divided by d, that's just d, so it's d times r, right? D times r. Okay, now we don't know d or r, but we know that this is all equal to 90 pi. I'm going to make a little bit more room down here. I don't think we need this anymore. All right. So let's see. What do we do next? Well, we know we can compute d in terms of 12 and r. D, what's d? D is equal to the square root of 144, which is 12 squared, plus r squared. All right. So, so let's see. So we've got, and let's cancel the pi out. So now we've got r squared plus r times the square root of 144 plus r squared is equal to 90. Now, there's probably many different ways to go about this at this point. But one thing you might do if you're trying to go fast on a math counts test is you might think, oh look, this thing 12 here, that's in a lot of right triangles. Maybe this is a right triangle with integer sides. So for example, this could be 5 and this could be 13. That's one right triangle that has these sides. Or this 12 could be scaled up from a 3, 4, 5. So this could be, you know, if this was 4 times 3, you'd have 3 times 3, which would be 9 here, and then 5 times 3 would be 15 here. So that's one other option. You could start to try to think about which one is the most likely here. If you want, you can, one thing that is, we know that this 144 plus r squared is probably going to be a perfect square, because if it's not, this square root, it gets multiplied by r, it gets added with r squared, and you're going to end up with an integer. So you might think, oh, this is probably an integer here. And if that's true, if this d has to be an integer, then it's probably one of these right triangles. Like, so this is maybe 13 or 15, or it could be 4 times, well, if this one is 3, if this one's 3 times 4, then this is 4 times 4, this is 5 times 4, this could also be 20. There are different possibilities here, but you might just try those 3, right? You might try d is 20, d is 13. So we had d is 20, we had d is 13, and we had d was 15 as all possibilities. Those were 3 possibilities where you had integer right triangles. And it turns out that one of those works very well, and it's the 12, 5, 13 triangle. So if you put 5 in here for r, you get 25 plus 5 times, this is 13, and 5 times 13 is, oops, I did it again. This thing is going to be 65. 65 and 25 is indeed equal to 90. So, so what did they want to know? So now we know r is 5. What they wanted to know was the volume of the cone. All right, so that should be pretty simple now that we know the radius of the base. We can just compute the area of the base, multiply by the height, and divide by 3, right? So that'll give us the volume of the cone. So we have 1/3 of the area of the base times the height, and that's just going to be, the area of the base is going to be 25 pi. The height is going to be 12, and we divide by 3. This gives us 4. 4 times 25 pi is 100 pi. So the answer here is 100 pi. Alright, that's the end of this video. I hope you guys enjoyed it. I'm going to do another one covering problems 21 through 30. So I'll see you in there. Make sure to like and subscribe to the video. And yeah, I'll see you guys very soon.